if we're going to summarize a little bit here of the quiz fairly quickly, and then because there isn't too much new to learn, although there were, like you guys said, number 22. Now, nobody's asking about number 21. I think 21, you want to ask about 21?
Like
okay, because 21 is, there's a lot more to 21 than you may have thought. So we'll talk about that one. Because, like I've said on these quizzes, and you probably saw that a little bit on the first one, but there's a lot of concepts here and a lot of interconnections and relationships, and some of them are pretty obvious, and some of the homework problems are fairly easy, but then there's always going to be those kind of problems that are on there that may ask it in a little different way and really stretch you as far as how well do you understand these connections. And you can't really study for that other than just keep doing the homework and keep paying attention as we do this and ask yourself, quiz yourself on the various things. Like the graph, I've got another matching activity here today that you can do. You can work, it's like F and F double prime. But I'll give you the option. You don't have to do it. If you want to be working on the homework or the review exercises and those kind of things, but if you think it'll help, that's okay. Drawing an F prime graph from an F graph or drawing an F graph from an F prime graph is helpful, can be helpful in problems. I'm probably not going to ask you just to draw an F graph from an F prime graph, but being able to do it, I think, is useful and can help in some problems and so forth. But if we look at section 1.4, that was when we first talked about F prime and the notation of a derivative. And that's when we did some of those, and you'll see in today's homework, that's when there were some of those problems where you had to do, if you remember, we did like position, velocity, acceleration. Remember when we did those graphs? If this graph is going up like this, it means this graph is positive and increasing. It means this graph is this. Those connections about knowing slope and that kind of stuff. I mean, I'm not saying that's a big part of the quiz, but there are some questions on today's homework that ask you about that a little bit. Or things like if this is miles and this is hours, then understanding that the velocity is the derivative. Remember v, that'd be p prime. That's miles per hour. And this one is what? Miles per hour per hour. And that's a would be like v prime, which would be like p double prime. I mean, but so that's when we introduced that notation about derivative. We talked about those kind of things and rates. We're calling rates of change or slope and that whole idea. Then we also had in 1.4, we had that height equation and that velocity equation if you throw a ball up in the air. And it was number 54 on your homework from that page. You might put a star by that. You might go revisit that problem. About that, I told you that'll be kind of the calculator part of this quiz. We'll be working with that. So you might go back and revisit that page right there. Okay? 1.5 was mostly about zooming in on your calculator, and we're not going to have much of a calculator part. That's where we zoomed in. We saw that the line was straight. We said, hey, if you pick two really close points and do a slope, you get that. The main thing you'd have to do on that, the main kind of question you'd be asked there is, let's say I gave you an F prime graph. Let's say I gave you this F prime graph here, and here is 2. And then I ask you, what's F double prime of 2? If this is an F prime graph and I ask you for F double prime of 2, what are you going to do? You're going to sketch in a tangent line right here, right? And you're going to do a little slope triangle business and estimate that slope and do kind of a rise over run, right? And so that, to be able to do that, just understanding that notation. So those are the things we did before we got into all this chart and connections kind of stuff. So, we've been focusing on that for a while, so I think it's important that we mention this, okay? 1.6, of course, and 1.7 is that, that's really when we got into the chart, and that's really when we get into all these connections between F and F prime, and we've been spending most of our time doing that stuff. So that's the stuff that you're probably most familiar with, at least right now. Some of those other things would be kind of the things to go back and I've assigned some of those problems. Oh, also in section 1.4, we're going to talk about that today because that's number 21 and 22, is the speed limit law. Okay, now you might not have known you were doing it. Well, they said it in 22, but in 21 you kind of needed that same idea. And all the speed limit law says is if you know something about how fast you're going, then you know something about how far you went. In other words, if you know the slope of a graph, then you know something about how far it goes over and up, rise and run. So if you know the slope, meaning if you know the derivative, you know something about the rate of change of the graph. Okay? So that's it. I mean, that's a main, that's kind of a quick overview of those things. Okay? All right, let's talk about 21 and 22. Okay? 21 and 22. Now, 21, I wonder, let me see, I got this pen I can write with, but I can also, I think I can write over top of this. I wonder if I can write over top of this. This pen. Oh, much better. Now I can erase that red line, but I can't erase that. No, okay. All right, so at 21, all right, so what does 21 say? G prime at 1 is negative 4. Is G decreasing at x equals 3? Justify your answer. Now, I want to say that 21, would you have to answer a question like 21? Absolutely. Or 22? Absolutely. There'll be more of those, more questions though, like 15, 16, 17, 18, 19, and 20, than there will be ones like 21, 22. Now I'm guessing 15 through 20 you thought weren't too bad. Would that be accurate? Okay. Like on 15, what do they say on 15? Let's back up here a minute before we go any further than 21. They tell me this is G double prime. On the chart, if I go back to the chart here, if this is G prime, G double prime, what do I mostly care about with G prime? Well, I mostly care about when it's positive and negative, G double prime, right? So if I come back to this, I mostly care that this is positive, then it's 0, then it's positive, then it's 0, then it's negative, right? Now that's when it comes to G, right? G double prime, remember, tells me mostly what about G? Concavity, right? G double prime mostly tells me concavity about G. Now what's G double prime tell me about G prime? Slopes, right? G double prime is the slopes of G. G double prime is the slopes of G prime. So it tells me a lot more about G prime, doesn't it? Now that gets into, now I would care when G double prime is decreasing, because that's when G prime is concave up, right? That doesn't tell me anything about G, but it does tell me some of those things about G prime. Okay, so it just depends on what the questions are. Okay, so 15 says what? G concave up. So according to the chart, G is concave up. G is concave up when G double prime is positive. Okay, so I'm looking here at from 0 to 3, and it is okay to include the 1 there. Okay, I don't have to go 0 to 1 and 1 to 3, okay, because there's no change. The only time a graph has no concavity, either it's a line or it's changing concavity, okay? So in this case, since it doesn't change concavity here, we can say that since G double prime is positive all the way to 3, that G is concave up that whole time, okay? Now, what's the next one say? Where is, so just say 0 to 3. G prime decreasing would be when G double prime is negative. So from 3 to 4, right? Again, that comes off the chart. But again, it's because G double prime is the slopes of G prime. So when G double prime is negative, G prime is decreasing. Okay, what was next? Does G have a point of inflection here? And what was the answer? Yes or no? Does G have a point of inflection? To have a point of inflection, you got to change concavity, which means G double prime's got to change from positive to negative. And it does not. G double prime is positive and then stays positive. But what about here at 3? We do have a point of inflection on G because G double prime's positive to negative. So G, did it say justify your answer? Whenever you have a local max min or a point of inflection, it usually says justify your answer. You need to be very specific on this. Now, I may be a little bit lenient on this first quiz where we're doing this, but on the AP test, they're very specific about this. When they say justify that that's a point of inflection, you have to use both rows of the chart. You have to say when G double prime, it's a point of inflection because since G double prime changes from positive to negative at 3, G changes from concave up to concave down. That's why it's a point of inflection. You really need to talk about both G double prime and G prime. Anytime we switch columns on the chart, we need to do that. We need to say since this one goes from this to this, it means the other one goes from this to this. Same thing with local max and min. Okay? What's the next one? Point of inflection at 3, was that right? And then what's the next one? Equation tangent line? Oh, right, that's a good one. G prime, they ask us rank these. G prime of 0, G prime of 1, G prime of 2. Somebody want to explain that one? First of all, what order are they in? That order. They already are in increasing order, aren't they? Somebody want to tell me why? Okay, a very simple explanation would be, now we went into a more difficult one in the other class, but a very simple explanation would be, since G double prime is positive all the way to 3, G prime is what? Increasing. I mean, straight from the chart. Since G double prime is positive all the way till 3, G prime is increasing. So therefore, the G prime Y values at 0, at 1, at 2, at 3 have to be getting bigger. Right? That's it. Now, in the other class, they wanted to draw a graph. All right? Now, there's nothing wrong with that. Somebody in the other class, whoever I called on, wanted to draw a graph. All right? So let's say we're going to do that. So if we're going to draw a G prime graph, now where do we start? We don't know, right? We don't know, okay? So G double prime is in your book there. I need a split screen here or something. So what is that graph? So what's G double prime going to do? I don't know, let's say it starts here. Okay, out there at what, -4? So it's got to go up, but isn't it leveling off? And where's it going to flatten out? Isn't it going to flatten out there at, is it negative? Isn't it at negative? Wait, what did I do wrong? Oh, yeah, x-axis. This one goes from 0 to 4. I was thinking of a different one. Okay. Okay. So we're now over here. So it starts. So let's say it starts right here, right? And so it goes up like this, and flattens here at 1, right? And then what? It comes back up, so it switches to this, right? So its slopes are positive and getting more positive, right? And then that corresponds, is that at 2? And that would correspond to what? The max there on that graph? Is that right at 2? That's not right at 2, is it? It's a little past 2, isn't it? So isn't it going to, okay, that's, oops, that's there. There's my inflection point right there, right? Little past 2. Okay, then what happens at 3? Isn't that flatten out now? Isn't that going to be a local max? And then it's going to come back down, right, until 4. Isn't that going to do something like that? Okay? All right, so here's my inflection point. So this is G prime of 2, this is G prime of 1, this is G prime of 0, and this is G prime of 3. So clearly they keep getting bigger. But again, why? Well, that graph's got to keep going up all the way from 0 to 3 because it slopes, G double prime, are positive the whole time. So they did a graph. So that's where this practice of having a G double prime and then graphing G prime can come in handy. It could have helped you answer that question. But you didn't need that. You could have done just what Nolan said. Since G double prime is always positive, G prime is always increasing. All right. Now, we got to keep this in mind because this is going to help us on number 21. Okay, what number are we on? 20. Okay, is G prime of pi greater than 3.5? Well, if we come back to this, pi would be about here, and 3.5 is right down here. What do you notice about G double prime that whole time? Yeah, but what, it's not decreasing we care about. It's negative we care about. So G double prime is negative this whole time, which tells me G prime is decreasing. Since G prime is decreasing, this point here, further left, has got to be bigger than this point here, right? So G prime of pi has to be bigger than G prime of 3.5 because the graph's decreasing. So the graph's going down, so the point to the left is bigger than the point to the right because it's coming down. Okay? So now we're on to 21. All right, now here is where this gets, here's where we have to think a little bit beyond what we have up until now. They asked me, and did I have that over here? Okay, here's 21. So they're asking me, they're telling me G prime of 1 is negative 4. Is G decreasing at 3? Well, now that's an awful tough question to go from G double prime to G, right? Is G decreasing? As a matter of fact, if I go look at the chart, here, and G decreasing, I got nothing on G double prime, right? It's empty. So G decreasing, I got nothing here for G double prime. The only thing I know is if G's decreasing, what? G prime's negative. So then the question where they say is G decreasing at x equals 3, that's not the question I'm going to answer. The question I'm going to answer is G prime negative at 3? That's the question I need to answer. Because if G prime is negative, then I'll know G is decreasing. Can I answer if G prime is negative? Well, yeah, look what we just did here. Weren't we just drawing a graph? Didn't I just draw a graph of G prime? Now, is G prime negative in my little graph at x equals 3? No, it's way up here. But why does that not help me? Yeah, I started this graph just randomly somewhere, right? Where do they tell me this graph starts? They tell me that G prime of 1 is negative 4. So this point actually needs to be way down here, right? So this graph needs to have been kind of flat and then come up and then keep going up and then now I kind of did that on purpose. What do I care about? What am I trying to answer? Is this graph I'm drawing negative at 3? So is this graph going to be down here below the x-axis? Or is it going to be up here above the x-axis? Now I'm just doing this kind of rough sketch. You know, looks to me like it could be darn close. So what do you think? Where is it? Is it going to stay down? Is G prime of 3 going to be down there negative? Or is it going to go up high enough to be up in the positive? Is there anything we know? Is there anything about G prime that tells me how fast it goes up or down? What tells me about how steep a graph is? It's slow, right? That's what tells me how fast a graph goes up or down, right? So how fast does G prime go up from 1 to 3? G double prime will tell me that story. So here's G double prime right here. What do you think? It's there. It's all, everything we need is right there on that graph to tell us how fast that G prime graph is going to go up. You got all day.
Doesn't go up that fast.
Why?
It's zeroing.
Well, but we knew that. I mean, right. It is a speed limit law. We knew, but in a little different way than we're used to seeing the speed limit law. Look, we know it's 0 at 1. It's flat, right? And we know it's 0 again at 3. We know it's flat. But what we're looking at is how fast does it go up in between 1 and 3?
I what happened again.
Aha. Okay, now we've talked a lot when we look at a graph like this, because these y values are the slopes, right, of the G prime graph. These y values are the slopes of the G prime graph. Now we've talked a lot about, hey, they're positive and getting more positive and negative and getting more negative, right? But we haven't talked very often about what they actually are, what their values actually are, right? So between 1 and 3, we were talking about how this is positive, right? It's above the x-axis, so therefore the G prime graph's going up. But now let's talk about what their values actually are. You guys are telling me these values are all what? They're all below 1. What's that tell me if a slope is below 1, or if it is 1? But let's do rise over run. If you go over 1,
Right, no more than one.
you're going to go up 1. In this case, we're going to go even less than 1. And you go over 1 again, it's going to go up less than 1, right? And so let's go back to our G prime graph. Where did we know we were? We knew at 1, we were down here at -4. How far over are we talking about going? We're talking about going from 1 to 3. We're going over 2. If I go over 2, how far up am I going? Can't even go 2, right? Because the slopes are always less than 1, so the most I can go up is 2, or even not that much. G prime of 3 has to still be negative. And since G prime is negative, G is, which was the question, right? The question was, is G decreasing? Yeah, you got to be able to get into it that deep on some of these things. So a lot of times we look at a graph and we're saying, hey, those y values are the slopes, and we just care if they're positive or negative, meaning going up or going down. But then we might have to look at the actual y values to see how fast it's going up or going down. Because that's a speed limit law. The speed limit law says how fast you're going. That tells you how far you're traveling. Well, that's what we're talking about the G prime graph. How fast is the G prime graph going? That's what G double prime tells you, right? How fast is it going? Tells us how far it went. In those 2 x units, it could have only went up 2. So since G prime's negative, G has decreased. So there's a lot there in that question, okay? Now, that's not a huge part of the quiz, but it certainly could be a part of it. The speed limit law, some way, somehow, will be a part of it. Now, I think 22 is actually easier than that one. 22 says what? They tell you that G, or no, it says F, doesn't it? It said, what's it tell us about F prime? F prime of, and it tells us that F double prime is between 0.1 and 0.5. Now let's just stop right there. Now it says when x is between 2 and 4, right? So at least during that, when x is between 2 and 4, this is true. So tell me what they just told me right here. They told us the slope, right? The slope of f prime. They told me a point on f prime. So they told me where I am on the f prime graph, which I'm going to plot that here in a second. They told me where I am on the f prime graph, and they're telling me how fast the slope can be of the f prime graph. So that means that if I go over 1, yeah, somewhere in between. So if I go over 1, I have to go somewhere between 0.1 and 0.5 up. That's what that's telling me. Okay? So if I'm gonna answer this, and then they ask me, then they want to know something about f prime of 3, right? They're asking me something about f prime of 3. So what this is saying is f prime of 2 is -1. So here's my f prime picture. And it tells me its slope is between there and there. So if I go over to 3, which is what they're asking me about on the f prime graph, so if I go over 1, I can go what? I have to go at least 0.1. So somewhere between those 2 points is where f prime of 3 has to be. So f prime of 3 has to be between, what's the biggest one? -0.5, right? If I go up 0.5, and the littlest one is -0.9. So they ask for an upper and lower limit, or lower bound. There it is. Just write it like that. -9 to -0.5. F double prime, or f prime of 3 has to be somewhere between there. But again, that's just speed limit law. That's just saying that, okay, I told you you're here. This is how fast you can go, right? This is the slope. It's got to be somewhere between there and there. There you go. All right? So we hadn't done much with the speed limit law. That was back in section 1.4. The reason they bring it back here is because now we did it with f prime, f double prime, which we said, remember, that's the same relationship as f and f prime. F prime is the slopes of f double prime is the slopes of f prime. All right. Yes, Brittany? What's 25? Oh, that's, okay, you just like the answers? The key is on the f double prime, and you can do this matching here, is f double prime tells you concavity. That's essentially it. So A is graph what? 4, B is 3, C is 1, and D is 2. Okay? So now, questions about that, Brittany, or did you just want to hear the answers? Think you got them? Did you mess them up? Well, we're going to have some time today, and we're going to do that f double prime and some matching so we can talk. Okay. There is one other problem I wanted to show you. Let me make sure I've hit everything here. Okay, one other thing I wanted to show you, and then I wanted to give you some work time here. Oh, I know what I wanted to do. 2 other things. Turn back to page 62, please. 62. All right, now, yeah. Here is, this was on your homework the other day, 37 through 45. 37 through 45. Now, I want to just reiterate to you that this will be a kind of a major piece of being able to do the problems here. Now, this was G prime, I think, or F. Was it F? What was it? F prime. This was the F prime graph. And then they ask you a bunch of questions about F and possibly F prime. So this is something we really want to be good at. So first off, if this is F prime, what are the things that I should really focus on, first of all, before I even answer any of the questions? Those are big. This is positive, and this is negative. Do I care about that? That's an inflection point of F. So will this be an inflection point of F? Okay, this will be a flat spot of F, which makes it a stationary point and an inflection point, right? So those will be, now, so if you just really understood all of that we just did right there, that's really good. Without even looking at the chart, if you kind of got those things, that's really good stuff, all right? So now you go through, and I don't want to spend a lot of time on it, but then it says, where is F increasing? Well, that's when F prime is positive. So from all the way to 4. We can even include that point there. Okay, let me skip down a little bit. Where, on 41, where does F have a local minimum? Where is there a local minimum? Isn't it that one right there? Okay, when F prime is 0, you can have a local min, local max, or flat spot. Well, to tell if it's a minimum, F prime has to go from negative to positive, because that tells you F is decreasing and increasing. So that's a local minimum. So now, what I want to make sure you understand is this is how you answer that question, though. Don't put F of -3. Don't put F prime of -3. Write X equals -3. Where is there a local minimum? You write it like that. Okay? Same with where are there stationary points. Is F concave up at 2? Justify your answer. I think it's no, isn't it? Is F concave up at 2? Why is it no? This is F prime now. Okay? It's because, oops. Concave up on F means F prime has to be increasing. And the F prime graph was actually decreasing. So you would say no, and then again, because it says justify your answer, you need to make these connections. Since F prime is decreasing, F is concave down at X equals 2. That's how you would want to justify that answer. Make the connection between F and F prime. All right? And then number 45, equation of tangent line. They give you the point F1 of 3, so you need what? Which means you need F prime of 1, right? I want you to get used to that notation. Well, F prime of 1 is just this point right here, right? Which is a 2. So now all you do is y equals 2, x minus 1, plus 3, and there's the equation of tangent line. Very simple. Really not much to do there. They give you the point. All you needed was a slope. Put it into your point. All right? Now, I did forget there was one other one I wanted to talk about in the book. So I'm sorry. I've got a couple more things. Problem number 5. They told you that F of, what was it, -3? I think I talked with some of you about this, but it's really important. We need to talk about it some more. -1, this was number 5 back on today's assignment. They told you F prime of -3 was 0, and they told you F double prime of -3. And they asked if there was a local min at X equals -3. Yes or no? And what did you say? Yes. Now, in the other class, what came up was, and now why, and people were talking about extra information. Well, there is some extra information, but this alone is not enough, right? What is the fact that F prime is 0 there mean? So there's 3 things it could be, right? Local min, local max, flat spot. Now, if you take local min, that looks like that. Local max looks like that. Flat spot looks like that. So what else do you need here? That right there. Because look, a local minimum is concave up. A local maximum is concave down. A flat spot isn't either one. That's how you can do it. That is actually has a name. That's actually called the second derivative test. Remember, the first derivative test is to tell if you have a local maximum in. But the problem with the first derivative test is you got to look on both sides of a stationary point. You got to see if it's increasing then decreasing for a max, or decreasing then increasing. The beauty of the second derivative test is if you know you have a stationary point, you know it's one of these three. Just look at the second derivative. If it's positive, it means it's concave up. You know you have to have a local minimum. Now, go to number 6 then. Why was that answer no on number 6 if it's not a local minimum or whatever to ask for? Did we do number 6? Is it a local max?
No.
Because it's not a stationary point. Since f prime doesn't equal 0, it's not even a possibility. You don't have to go any further than that. Since f prime did not equal 0 there, it's not a stationary point, can't be a local max. Okay, it's just a different way of asking that question. All right, we do have time here, so let's. There's one more little thing I want to show you. It really leads more into next. It really leads more into next chapter, but I do want. There could be a little piece of this you might have to do for the quiz. So let's say we had this right here. Okay? Let's say I would gave you this. Now, mostly the quiz will be about graphs that I give you, reading off graphs, maybe some questions about points and various things like we just talked about in number 5. Didn't give you the graph, but gave you some information. Chapter 2, we're going to really start dealing with equations more, okay, and how that all works. But we should be able to handle a fairly simple one here. So this would be the question. F prime is that. Find all local extrema of F. And again, I'm keeping it a fairly simple equation, so it's something you should be able to handle without a calculator, without graphing. Okay? So, tell me what you guys think. No calculator. Okay, aren't we interested in where f prime is 0? Stationary point. So couldn't we set that equal to 0? Now, I heard somebody say parabola, right? Even though we don't have a calculator to graph it, we do know about parabolas, right? This is a parabola that opens up. The only problem with this is, unless we really want to get detailed and graph it, a parabola that opens up could do that. Now, what's a problem there? Never touches the x-axis, so it's never 0, so there'd be no local extrema, right? There'd be no stationary points. A parabola that opens up could also do that. What's that mean? Only has one stationary point, and what is it? What is it of f? Is it a local max or min or a flat spot? Isn't that a flat spot? Because f prime is positive and then stays positive, so f will be increasing, flatten, and then increase some more. Right? Or it could do this. And then we would have 2 local extremes, right? What would this one be? Local max or local min? Isn't that a max? Because f prime goes from positive to negative. This is a min because f prime goes negative to positive, right? So this would have both. All right? So maybe you thought of parabolas and maybe you thought of graphs, and that, I think this comes into play in one of your homework problems today. But I like what Sam's saying is, can't we just do this? I mean, I hope you guys can solve this, can't you? My Algebra 1B class can be solving these in about 2 weeks, so I hope you guys can. I won't put the pressure on or anything, but what would you do here? Factor that. Nobody said add 2, right? I hope nobody said add 2. We're going to factor it, right? We're going to get 0 on one side. And then we're going to have what? Plus 2 minus 1. And then set each of those equal to 0. So x is going to be. So which of these 3 situations do we have? The third one, right? Now, since we now know that it's that situation, and since we know this is a parabola, we could then say, oh, well, this, and we know that this parabola opens up because it's got a positive leading coefficient. Remember how I said it's important to know these basic graphs, okay? So since we know this is a parabola opening up, and we know it has two roots, we know this graph's going to do that. Well, now don't we know where the local max is? Local max is at -2. The local min is at 1. And so we can now answer that question, right? So combining what we know about graphs and then what we know about solving equations. Now, we're going to get into that a lot more in Chapter 2. Now, sometimes we don't have such a simple equation. We solve it. Sometimes we use our calculator to solve it. We'll do something called a number line. You don't have to worry about this right now. But another way to show this same piece of information, in other words, we want to see this positive, negative, positive thing. Another way to do that is just make yourself a little number line and then just take some values that are in between here and go back and plug them into f prime. Right? If we have a graph, it's easy to see. But if we don't have a graph, we can just take, say, a -3. We can plug it in there. That'd be -1. That'd be -4. -1 times -4 is +8. So I get a positive there. Here I put in a 0, I get 2. Put in a 0, I get -1. 2 times -1, that's a negative. Take a 2, plug it in, I get 4 times 1, that's a positive. So this number line tells me the same thing this graph tells me. Because some functions I get are too complicated to graph and know what their graphs look like. And so I can just find out where it's 0, and anywhere it's 0 on the other sides of that, it must be either positive or negative. Right? If I know all the places where it's 0, then on the other sides it must be that. So now I know I have a local max right there, and I have a local min right there because of that positive, negative min. So that's where we're headed with this, being able to use equations and so forth to do that as well. Okay, but this quiz will mostly be about the graphs and those connections and so forth. All right, that's what I have. The rest of the time is going to be for you to work on a variety of things that you feel you need to work on. So if you would look at your assignment sheet, okay, if you look at the assignment sheet, all right. Now I would say on that now basically your assignment for tomorrow is the 1.7 day 2. So that gets into some more second derivative things, and it does get into some of that where it asks you about graphs and units, like a first derivative, second derivative. There's a, remember the thing we talked about, the child is fever is rising, but since he took the medicine, it's not rising as fast, right? A lot of remember those questions a while back? A lot of that had to do with concavity, concave up, concave down. So it kind of fits in with what we're talking about with positive, or with second derivative and so forth. So there's some of that, thinking about the units, and you can get into some of those a little bit. Not a big part of the quiz, but there might be one little thing, point here, a couple points there, maybe something to deal with that. Okay? So that's 1.7 day 2. Then on the review, I would ignore up through number 11. Those are things that are from early in the chapter, so I wouldn't worry about those. But starting with 14 on, those are the ones that are more involved with what will be on the quiz. 28 through 33 is speed limit law stuff. Now, for those of you that are going to be here and not miss any time, you'll have time to be working on this tomorrow in class. If you're going to need to be working ahead and getting ready for the quiz, you might want to spend time on these. 28 through 33 is speed limit law. I think 41 through 51 gets into some speed limit law if you feel you need some of those. There's another set of speed limit law in the late 50s. I didn't even put them on the assignment sheet, but they're there if you want to look at those. Again, there's not going to be tons of speed limit law stuff either. I mean, one of them here or there. But there's a lot of good stuff there in the review section about increasing, decreasing, the chart, those kind of things. Okay? So you could be working on those things. I do have another matching activity here if you want to do it. It uses f and f double prime, okay, a graph and its second derivative. If you want a copy to take with you, instead of to do it here during class, I've got some copies and I can make more, okay? Now, but with this one, I not only have a graph and its second derivative, but I also have a page of first derivatives that goes with it. I think it's worth just doing some f double prime matching, but then if you want to come back and match in the first derivative, I've got copies of those. And for the graph and its second derivative, I've got a sheet you can write them down. I got the key up here. And we're not going to turn it in for grade or anything, so it's just up to you if you want to do it, okay? And I'll post the answers. I'll post the answer sheet for this activity on the School Fusion page too. Okay? All right. Go ahead and work on any of those things that you need to, and ask questions and get some help if you got some things bugging you. You bet. How am I doing? Do I need some more copies?